Let's consider an example of a chain rule. So my example is find dy dx of sine 2x. So as you can see, my function is given as y is equal to sine 2x. So basically, if you look closely, you will see the function is y is equal to sine of a function 2 of x. So basically the function is y is equal to sine is a function, and that sine has 2x as a part of that function. So basically this is more like a composite function, right? So what we are going to do, we are going to treat this function as y is equal to sine and then also a 2x. So let's differentiate both sides. So what I'm going to do, I'm going to differentiate this function. So if I differentiate, I will write dy dx of y that is equal to dy dx of sine 2x, right? Which is basically my function from here, right? Now let's differentiate, and if I differentiate this function, I will write this one as dy dx of sine 2x, right? This is basically my sine function, sine of something, times dy dx of 2x, right? Now let's differentiate. So dy dx of sine function is cosine, so I will write cosine of a function, right? Cosine function times dy dx of 2x is basically what? 2 times, and the differentiation of x is 1, so I will write 2 times 1. So as you can see, 2x is basically 2 times x, where 2 is a constant, so I can take out 2 outside, and then I will find the differentiation of x, which is 1. So differentiation of 2x is basically 2 times 1. Now let's simplify further, and if I do that, I will get 2 times 1 is 2 times cosine of 2x, right? And this is the differentiation of the given function sine 2x, right? Now let's differentiate another function. So my example is find the differentiation of y is equal to square root of x squared plus 1, right? So as you can see, my function is basically what? I need to find the derivative of this function, and my function is basically square root of something, and then the function is also x squared plus 1. So basically this is a composite function. So let's differentiate, and if we differentiate, we will write dy dx of y is equal to dy dx of square root of x squared plus 1, right? All right, now let's simplify. So if we simplify, we will have dy over dx on one side, that is equal to dy dx of square root of x squared plus 1. This is my function f of u times dy dx of x squared plus 1, right? Now I'm going to treat this one as a square root of x, right? And so what I'm going to do, I'm going to differentiate this first part of the function, and then I will bring the value and I can substitute. So let's differentiate that part. So my function is basically what? dy dx of square root of x squared plus 1 is what? X squared plus 1 to the power 1 over 2, right? And I'm going to treat this one as basically this one as my u. So u to the power 1 over 2. I'm going to use the power rule. So when I use the power rule, my differentiation for this function will be what? 1 over 2, and then u, which is basically what? X squared plus 1 to the power 1 over 2 minus 1. Let's simplify, and if we do that, we will write 1 over 2 and then x squared plus 1. This is my u of the function, and then 1 over 2 minus 1 is negative 1 over 2, right? Now let's simplify further. As you can see, I have a negative exponent, so I want to make it positive, and one way I can make it positive if I take it to the denominator. So I can simplify this and write it as 1 over 2 times 1 over x squared plus 1 to the power 1 over 2. Now let's simplify further, and if we do that, we will write this is equal to 1 times 1 is 1, and at the denominator I have 2 times x squared plus 1 to the power 1 over 2. So I will write 2 times, anything to the power 1 over 2 is basically what? Square root. So I will write 2 times square root of x squared plus 1. dy dx of x squared plus 1 to the power 1 over 2 is right here, right? So what I'm going to do, I'm going to substitute for this differentiation, I'm going to substitute this term right here. So let's go back and substitute over there, and if we do that, we will write this one as dy over dx is equal to, this thing right here is 1 over 2 square root of x squared plus 1, right? And differentiation of x squared is what? 2x, right? Plus differentiation of 1 is 0, right? So 2x plus 0 is 2x. So if I simplify further, I will write this is as 2x over 2 the square root of x squared plus 1. Now, as you can see, I can cross this 2 out, and if I do that, I will write this one as dy over dx is equal to x over the square root of x squared plus 1. And this is basically my differentiation for this given function right here, right? So as you can see, this is how we can use the chain rule to find the derivative of any given composite function.